Okay, good morning once more. I am Emmanuel Tadjuidje. I am originally from Cameroon in Central Africa, and I've been at Alabama State for 6 years. So this is a view of the Alabama State campus. You can easily recognize the football field here. Can you see my cursor?
Yes. Okay.
Okay, yeah, you can easily recognize the football field here. And here, highlighted in yellow, is the Life Science Building, which is where the Center for Nanobiotechnology Research is located. It is also the home to the biology department, where I'm also a faculty, and also it houses our PhD program in microbiology. So when I got to Alabama State in 2016, I entered a department where everybody was doing microbiology. So, and I thought it was a good idea to bring my area of expertise, which is developmental biology, and especially using the African cloud frog Xenopus laevis as a research model. That's why developmental biology, oh, my slide will not move forward. Why won't it move forward? Okay, so why developmental biology is just because developmental biology, it's a very, it's a multidisciplinary field. And if students that are being trained in developmental biology actually have the opportunity to try different, they have the opportunity to navigate different field of life science, all the way from cell biology to bioinformatics. And in doing that, they can learn about a lot of important biological processes, which are listed here. And why Xenopus? Xenopus is a very elegant model organism. The embryo developed outside the mother, which means it is available for manipulation at every stages, from the egg all the way to the froglet stage. And there is a panoply of manipulations that you can perform at every stage of development. And also there is a panoply of processes that you can study using embryos at different developmental stage. And more importantly, those embryos, because they are readily available, they can be treated at every stage, at any stage, with chemicals for toxicological studies, and also with drugs for pharmacological studies. So when I joined the REACT project, in the center, Dr. Singh was interested in looking at the biological effect of carbon nanotube. There are a lot of faculties in the CNB are using different type of nanoparticles for research, but most of the biological testing that we have been able to perform were using cell lines. And we thought it might be a good idea to use an actual in vivo model to test the effect of nanoparticle. At that time, we had silver, okay, just a short, I mean, this is, you know better on those nanoparticles that I do. What I know is that as it relates to carbon nanotubes, because of their hollow structures, they can be filled with drugs, and that can be used for target delivery, like delivering vaccines or delivering cancer therapy. So in the lab at that time, we have single wall nanotubes coated with silver. And I had a student who just joined my lab, Miss Shakira Patrick at that time. And we decided that it would be a good thing for her to just take what we had at that time and treat embryos and see what happens. So what we did was she cultured embryos to the neurular stage. This is making sure that the embryos are actually properly developing, so that any effect she sees will not be, cannot be attributed to just a random defect early. So we treated cultured embryo to the neurular stage, and we treated them with the nanoparticle, and she counted death and looked at morphological changes until the tadpole stage, which was the terminal analysis stage. What Shakira was able to show was that single carbon nanotube either dissolve in plain culture medium, as shown up here, or dissolve in using a dispersant like BSA. Overall, what she observed was that nanotubes can actually cause some obvious the developmental defect on the embryos. As shown here, you see the normal looping of the gut, and a high proportion of those embryos also show edema, which is due to the accumulation of fluid in the extracellular space in tissues. So we were able to also obtain multi-wall carbon nanotubes, and by that time, Shakira was joined by two undergraduate students, Michaela Robinson and Hagia Abdelmagid, and together they tested the single-wall nanotube and multi-wall nanotubes and compared their different effects. And what we observed here was that overall, the single-wall nanotube, whether coated with silver or not, caused more severe effect than the multi-wall carbon nanotube. So far, Shakira has graduated, and it is going to be up to, Shakira has graduated with a master's, and she's now attending a PhD program in New York. So it's now up to Michaela and Hagia to continue. What we want to do is now start the treatment at different developmental stages, and also freeze embryos and do gene expression analysis to determine which type of genes are being affected that cause the observed effect. What we're also planning on doing is actually sectioning these embryos to see in order to perform more histological analysis to determine what actual effect, what are the actual defect on tissues in those embryos that shows the phenotype that we observed. Now, during the course of this project, we were able to acquire, owing to the REACT funding, we were able to acquire two dual-headed teaching dissecting microscope, which have been very instrumental, not only in helping carry on the project with Michaela and Hagia. It had also been very helpful to me because I also teach developmental biology labs for biomedical engineering students. So these scopes have actually been very helpful in allowing me to carry on those classes with a lot ease than with the microscope that I had before. So this being said, I'm open for questions.